Welcome to today's explainer. If your automation depends on CAPTCHA solving, the absolute biggest risk you face isn't always the CAPTCHA itself. Nope, it's the queue, the retries, the monitoring, and, honestly, the total lack of ownership when something goes wrong. So let's take those risks and transform them into a seriously reliable architecture for your workflows.
So, let's kick things off with an incredibly practical question, one that exposes a true, real-world vulnerability in client-facing automation. Can you actually tell when your CAPTCHA pipeline is starting to fail before the client even notices? It's a question that makes a lot of engineering and ops teams sweat, right? And for good reason.
To figure this out, we're going to quickly walk through 5 key areas today. The silent pipeline failure, our 6 steps to reliability, mastering error retry rules, tracking key pipeline metrics, and finally, ownership and safe automation. Let's get right into it.
Part 1. The silent pipeline failure. This is exactly what happens when tasks just pile up completely unnoticed. A lot of teams treat CAPTCHA handling as just a minor technical step. A task comes in, the solver runs, a token comes back, and boom, the workflow continues. But viewing this as just a simple developer utility is a mindset that absolutely sets you up for failure. Because that works perfectly fine, right up until it doesn't. One day, the queue silently starts growing. Suddenly, a client is asking why a report is late. A developer points out the solver is throwing errors, and meanwhile, operations has literally no idea if the issue is a zero balance, high concurrency, a network timeout, or just terrible proxy quality. In that exact moment, this isn't a code utility anymore. It's a full-blown operational reliability crisis, and everyone is scrambling.
Moving on to Part 2, 6 Steps to Reliability. This is your practical checklist for managing automation.
These 6 steps we're about to cover, they are the critical bridge between a chaotic, shared flow and a highly resilient, production-ready system. Implementing them is what actually transforms a fragile script into robust infrastructure.
Okay, step 1 is separating tasks clearly. What this means is you have to link every single task strictly to a unique client ID and task ID. If you're managing multiple clients, do not, under any circumstances, let all your tasks live in one giant unclear shared flow. That is just a recipe for mixed results, reporting confusion, and totally wasted debugging time. Step 2 is defining strict concurrency limits per client. Look, not every client needs the exact same volume. One client might be running a massive scraping operation, while another just needs a few tasks processed every hour. You absolutely need distinct limits to prevent one heavy user from hogging all the active slots and slowing down the entire system for everybody else.
For step 3, you have to monitor the queue continuously. I honestly cannot stress this enough. Silent queue growth means your automation is failing long before a support ticket is ever opened. You should be actively tracking queue size, average solve time, pending tasks, and looking out for any overnight backlogs. If your queue is growing, you need to know immediately.
Part 3. Mastering error retry rules. It is time to stop wasting resources and hurting delivery.
The core idea here in step 4 is that not every error should be handled the exact same way. You've got to establish strict laws of automation. For example, a zero balance error. That shouldn't trigger endless retries. It should stop the queue immediately and trigger an alert. If there's no slot available, you requeue the task with a delayed retry. An unsolvable CAPTCHA gets exactly one retry, and then it's a clean failure. A network timeout needs a retry with a structured backoff. This logic stops you from either retrying too much and wasting resources or failing way too quickly.
Part 4. Tracking key pipeline metrics. You need to know exactly who is using what. Step 5 of our checklist is all about visibility. Tracking cost and usage by client volume, error rate, and concurrency is absolutely mandatory if you want proper pricing and client communication. If you're wondering what to measure first, start with these rapid-fire metrics: solve success rate, average solve time, queue size, and failure rate by error type. When you start tracking client-level volume, balance availability, and retry counts, you finally move from guessing to knowing.
Now, here's a question I hear all the time. Should you just increase concurrency when the queue starts growing? It's a super common reflex to just throw more workers at the problem, right? But listen, this can actually make things so much worse. If your real bottleneck is poor proxy quality, strict platform rate limits, or bad retry logic, jacking up the concurrency is just going to generate more 429 too many requests errors even faster. You've got to diagnose that root cause first.
Part 5. Ownership and safe automation. Who responds when the queue is actually stuck?
This brings us to step 6, which tackles probably the most common operational failure in tech. If nobody from engineering, operations, or support explicitly owns the workflow, every single incident takes way longer to resolve. You have to assign clear ownership for monitoring, billing, technical fixes, and client updates before anything breaks. When an alert fires at 2 a.m., there should be zero ambiguity about whose pager is going off.
It's also incredibly important to acknowledge safe automation practices. Safe use means you are deploying automation exclusively in owned, client-authorized, or contractually permitted environments. This is huge because automation workflows can create serious legal, contractual, or platform policy risks when used without permission. So the question isn't just, can this technically be automated? It's, is this workflow actually allowed under the current rules?
To wrap our heads around this quote really sums it up perfectly. A CAPTCHA pipeline is not just a solver connected to an API. It is part of a larger delivery system. You absolutely must treat this pipeline like critical infrastructure, not just a generic throwaway API call. So, here is your call to action. If your team depends on automation for client delivery, I want you to review just one related workflow this week. Start by establishing visibility into those metrics we discussed. Define clear ownership, and then, step by step, start improving the reliability of the whole system.
I'll leave you with this final thought to chew on. Think carefully about your own infrastructure right now. Is your automation workflow actively managed for reliability, or are you honestly just waiting around for the next massive, silent queue failure to halt your operations? Don't wait for the queue to break. Take control of your pipeline today. Thanks for joining me on this explainer, and I'll catch you next time.